This is section 11.7, talking about proportional segments with parallel lines. So we're still trying to talk about similar figures. For the warm-up, we just did a review of what we have done in the past. I think this was way back in chapter 4, but if we have a set of parallel lines and a transversal, you can find all 7 other missing angles if you're given one. So if this is 74, since these two angles form a straight line together, they must add up to 180. So 180 minus 74, that would leave us with 106 degrees. Then you can say, okay, well, if we have parallel lines, the corresponding angles are congruent. So this is 106, and this is 74. Then you could say, oh yeah, well, vertical angles are also congruent. So 74 and its vertical angle, 106, 106, 74 and 74, and then 106. So now, in this investigation, they ask, is this triangle, are these two triangles similar, VMT and the outside triangle, VLU? So, can we say yes or no? But if we have parallel lines, we can see, well, angle 1 and angle 2 are corresponding, so those are congruent. And angle 3 and angle 4 are congruent. And we learned that one of the rules for saying congruent are similar, triangles are similar, is by angle-angle similarity. So we can say, yes, they are similar by angle-angle similarity. So therefore, if we have a triangle created by a set of parallel lines within a triangle, the two triangles are similar. And they say if the triangles are similar, what do you know about corresponding sides? Well, then they're proportional. Had a couple classes say they're congruent. They are not congruent. Congruent means they're the same size, but they're proportional. They have this, all of the corresponding sides are multiplied by the same scale factor. So then we went in class, we went ahead and measured the side lengths and checked to make sure they're proportional. Turned out they were. Then we said if this, so we checked that is 4 over, here's my similar triangle, 4 over 5, and then we don't know this value, and then the big triangle was 16, right? 4 plus 12, and 5 plus 15 is 20. So we saw, oh yeah, 4 over 16 is the same as 5 over 20. Therefore, those are both a fourth. So yes, the corresponding sides are proportional. We also, some people pointed out, oh, well, you can also say 4 over 12 is the same as 5 over 15. So that led us to this next question of looking at this triangle. It says, separate each figure below into 2 triangles, then find the numerical values for the given ratios. So we could, and we know EC is parallel to AB, it says. So we can then try to solve for X. Some people went ahead and broke this into 2 similar triangles, and they said this is 8, 12, and we don't know what that value is. And then our big guy was 24, and this whole length is 12 plus X. And then they went ahead and set up a ratio. 8 over 24 equals 12 over, 12 over 12 plus X. So what a lot of people recognized was, oh, look at this. This times 3, 8 times 3, is going to give me my denominator, so then 12 times 3 will give me whatever's down here, 12 plus X. So 12 times 3 is 36. So we could set this up. 36 equals 12 plus X. And then go ahead and subtract 12, and we get X is 24. But then some other people pointed out, oh, well, look at this. 8 times 2 is 16, so this segment's double. And 12 times 2 is 24. So, and then if we look here, DE over AE equals 1/2, and DC 12 over 24 equals 1/2. So what we concluded then is this conjecture. If we have a parallel line to one side of a triangle, passes through the other two sides, then it divides the other two sides proportionally. So as we can see, this line, the parallel line, cuts these two sides, DA and DB, proportionally. It doesn't cut the third side, but it cuts these two sides proportionally. And then conversely, if a line cuts two sides of a triangle proportionally, then it is parallel to the third side. So we can then say, we could determine if a line is parallel if we have proportional segments. So now we can go ahead and look at these examples, and it says QN is parallel to LM. So let's apply this, and let's try to figure out what does X equal. So we have 25. We can look at these two. We know these two triangles are similar. But we also know, based on my parallel proportionality conjecture, that this parallel line cuts my two sides proportionally. So we could say 25 over 45 is going to equal 20 over X. Then we can go ahead and solve. Sorry, the dogs are going to bark. We could go ahead and solve, and we could cross multiply, or I could multiply by, or divide by 1.5. So I can say 20 times 45. So this is going to leave me with X is 36. I could also set up my ratio between, sorry, hold on. Okay. Alright, I'm sorry. We could also set up a ratio to say 25 over 20 is going to be the same as 45 over 36. Okay. So then let's look at two more examples. Now we have three sets of parallel lines, and it says, are these ratios equal? So X, if we have parallel lines, then we can solve for X. We can say, well, 21 relates to 42 the same way that 35 is going to relate to X, because they're cut proportionally. We can also say that's equivalent to 28 over Y. So now we can go ahead and solve. We could say, all right, well, let's solve this first ratio and proportion right here. And once we get X, we can solve the second. So we could say 21. So X will end up being 70. And then if this is 70, then I can solve again. And I would get Y is 56. Then they ask, is the ratio between FL and LG equivalent? And we know, is that equivalent to TA over AR? And we know that is true by our parallel proportionality conjecture. Finally, we have 4 parallel lines. So I could go ahead and set up my ratios. I can say C and over 21 is going to be the same as 25 over B, which is the same as 20 over A, which is the same as 10 over 14. Now I can just start doing one at a time. I'm going to start with this one because I have 3 of my 4 values. So I could say 20, if I cross multiply, times 14, divide that by 10, I end up getting A is going to be 28. Now I can add 28 in there, and I can solve this proportion. So I could say 28, and I would get B is 35. And then finally, C, I could solve this proportion. And I would get 15. Now you have to be careful because you can only say the divided sides are proportional, not the base. So that concludes that lesson. I'm sorry about the dogs. You can do your homework in the book.